Hello juniors. Today we're going to see kind of a short class. It's electronic assignment number 15, choosing a line of regression. And we're basically going to analyze a little concept that you need to consider whenever using this mathematical technique of regression or correlation between two variables. So the objectives for this class are the same as last class. Determine the linear correlation of bivariate data, find Pearson's product moment correlation coefficient R, find the equation of the regression line y on x, and use the equation for prediction purposes. Okay, so here it says, you can draw two different regression lines depending upon which variable you wish to approximate. So far, you have used the y on x regression line, but we can also calculate the x on y regression line, and this is often a different line, okay? We're going to see this in the practical example in just a second. So it says the y on x regression line is given by y equals a plus bx, or the same as saying ax plus b, which is what we use in a calculator, and allows you to estimate the value of y from a given value of x, okay? So we're using this equation when we have the known x variable and we want to know the value of y, or the predicted value of y, right? Then we have the x on y regression line is given by this equation over here. So you see that in this case, the x is solved or left alone, right? And this equals c plus dy, and allows you to estimate the value of x from a given value of y. So in case we're given the value of y, we need to use this equation in order to find the value of x, okay? A common mistake is that people usually find this equation, and when they're given the value of y, they would just plug in that value of y here and then solve for x. But that's a mistake. Actually, the value you get is different from the value you would get by doing this, okay? We're going to see that in the example in a second. Okay, then it says, if there is a perfect correlation between the data, remember that perfect correlation implies that R should be equal to 1, okay? Between the data, that is, if all points lie on a straight line, this is 1 or -1 also. Then the two regression lines will be the same. So only in the case we have a perfect correlation, then we can assume that we can use this equation in order to predict both x and y values. But normally this is not the case, right? We in a real life scenario, the value of R is very uncommonly equal to 1. It's normally a decimal number different from 1. Okay, so let's see this example in order to further understand what we just discussed here. So it says, the following table displays the height and shoe size of SAS juniors during the year 2020. Okay, so this is why I ask you to give me your heights and shoe size. So here you have the heights in centimeters, which will be our x variable in this problem, and the shoe size measured in the US system, which would be our y variable, okay? So you have all of the information from the 16 students in the class, and with this information, we're gonna do the following. It says, use technology to help you. A, find the regression equation y on x. So this is what you already know how to do, right? Which is go into menu statistics, then plug in the x variable in list 1, then plug in the y values in list 2, and then go to calc, reg, x. We're going to do that together now. So let's do part A first. So using GDC, you already know the steps, so I'm not going to write the steps again, but I'm going to show you here in the video. Okay, so this is the calculator, and what I'm going to do is I'm going to plug in in list 1, I'm going to plug in the values of x, which are 180, then we have 162, 172, 178, 180. If you want, you may do this on your own using your calculators. 166, 160, 175, 172, 176.5, 181, 178, 176, 164, 183, and 178. Once we plugged in all the x variables, we go to the y variable, which is shoe size: 10, 6, 8, 11, 10, 8, 6, 11, 9.5, 10, 11, 11, 9.5, 7, 13, and 10.5. So we have 16 pieces of information. We can see that here. So this is fine. So then we go to calc F2, reg F3, x, which is F1, and finally we could use either, but we're going to use this first one because we're used to that. So ax plus b, and we get these values. So if we go, remember the value of a represents the slope of the function in this case, and the value of b represents the y-intercept, okay? You see that we have a very strong positive linear correlation, right? This number is very strong positive linear correlation. So this number is a very good number, so we can actually say that there is a strong correlation between height and shoe size. So depending on the height of the person, the shoe size will also tend to increase. The higher the height, the greater the shoe size. So if we go back to the electronic assignment, I'm going to write the equation here. So the equation is y equals 0.25, I'm going to round it to 3 significant figures, 256x minus b, which is 34 point, this actually goes to 35.0, so 35.0 rounded to 3 significant figures. So remember, the x variable is the height and the y variable is the shoe size. So that's it for part A. We already determined the equation y on x. Then for part B, I don't know what's happening here. There you go. For part B, we're going to do the same thing, but we're going to change a little bit the settings. So it says, for B, find the regression equation x on y. So once again, we're going to do the same thing, but there's something that we need to change. Now we need to find the equation x on y. So that is that we need to have an equation that is x equals something y plus something, okay? So the same as this, but instead of having y over here, we're going to have x, and instead of having x here, we're going to have y. So how do we change that in our calculator? Simple. I'm going to show you. If we go back to the calculator now, let's go to exit. And you see that, exit again, here. You see that we plugged in list 1 the x variables and in list 2 the y variables. The calculator, as it is set up, it will always interpret that the list 1 is the x variable and list 2 is a y variable. But if you go to set, which is F6, we could change that. You see that here it says 2var x list, and we could tell the calculator to read that from list 2 now. Okay, so we click on F1 and put number 2. And we can tell the calculator to read the y variable in list 1. So we're going to click on list and put it 1. Okay, so now the calculator will interpret that this column over here is, this column over here would be the independent variable, and this column over here would be the dependent variable, which is the opposite as we had before. So we follow the same steps. We go to reg F3, then x, and finally we click on ax plus b, and you see that we're getting a different equation here, which I'm going to write now in the electronic assignment. So if we go back to the electronic assignment, we would write this as x equals, the value of a is 3.39x. If we round this to, this should be y plus 142. So this is our our equation x on y. Okay, so you see that it is a totally different equation from the first one we got here. One thing that you should notice that I forgot to mention you for part A is that the value of r, if you look at the value of r in both cases when you use the calculator, you get that if you look at the calculator, you'll see that the value of r in this case is the value of r is 0.932. And when you do the opposite way, when we have x in list 1 and y in list 2, you get exactly the same value of r, okay? So that doesn't change. Although we're not asked to do that, I'm just showing you this for you to know. Okay, so the value of r remains the same, although the equation changes. Then for part C, show both lines on the scatter plot with the height on the horizontal axis. Okay, so for part C, before I show you the graph, which I already made in order to save some time, there's one thing that we need to do with this equation specifically before we can draw this, okay? It says, show both lines on the scatter plot with the height on the horizontal axis, okay? So in both equations, we need to have the height as our x variable, right? So if you look at this equation, we cannot plot this. We cannot just write this in the calculator because the calculator always assumes that the equation starts with y equals something, okay? So what we need to do in order to be able to graph this second equation is we need to solve for y, that is, leave the y alone. So if we do that, I'm going to write that here from the equation, or the function actually, function in part B. If we solve for y, and then I'm going to solve it here, we're going to get x minus 142 equals 3.39y. And then by dividing 3.39 in both sides, we're going to get the following equation. Y equals x over 3.39 minus 142 over 3.39. Okay, so this is the equation that we need to consider in order to graph both functions and have the height as on the horizontal axis, okay? So now that we calculated this equation, we're gonna plot them, which I already did here. You see that this first equation corresponds to this one over here. I just rounded the answers to 3 significant figures. Here I wrote the complete decimal places. And this second equation is the same as this, okay? Once again, I rounded the values to have them to 3 significant figures. So you see that when I plot this, and by the way, these points over here are the points corresponding to the data that you gave me, these points over here, okay? So if you see both graphs, you'll see that both lines, the blue one is the first one, and the red one is the second one. Both lines are very similar, but they are still a little bit different, okay? So it's a common mistake, as I told you before, to use this equation to predict x values when we're given y values. And it is a common mistake to use this equation to predict y values when we're given x values. So that's something that you need to pay attention, but because you will get slightly different answers if you apply the wrong equation, okay? So that's something that you need to pay attention to. If you want to predict a y value, in this case shoe size, you need to use the first equation. If you want to predict an x value given a y value, we should use the second equation, okay? So that's the most important thing I wanted to transmit to you for this class. Okay, so let's go on with part D of the problem. It says, let me write that here. For part D, it says find the predicted shoe size. Remember, shoe size is our y variable to 1 decimal place for a new classmate who is 177 centimeters tall. Okay, so if we want to predict the shoe size, which is our y variable, we would use this equation over here, right? Because that's the one where we have the y alone, right? Solved already. So I'm going to take this here. Here. And I'm going to erase this. So if we want to predict the shoe size of someone who is 177 centimeters tall, we would just plug in the value of 177 into the x value. And this would be 0.256 times 177 minus 35.0. And by solving this using a calculator, we would get times 177 minus 35, we would get 10.3. This is rounded to 1 decimal place. So this is a US shoe size, okay? So that's the predicted shoe size for someone who is 177 centimeters tall. Okay. If we try to do this using this equation, this second equation in which we also have the y alone, you will see that we will get slightly a different answer. So let's try that just to show you that you get a different answer by doing this method. So I'm going to put this here, I'm going to erase this. I'm going to change the color of this because we should avoid confusion. So this is, I'm gonna clarify here that this is not correct. So if I try plugging in here the value of x, which is 177, we would get 177 over 3.39 minus 142 over 3.39. If we solve this using the calculator, we would get 177 over 3.39 minus 142 over 3.39, and we get, well, actually we got a very similar answer, but if we round to more decimals, then the answer would be slightly different. So in this case, it's just a coincidence, but we get kind of the same value, okay? But technically speaking, we should use this method to solve this. It's a conceptual or mathematical mistake to actually use this equation, okay? So let's see if for part E of this exercise, we can demonstrate that the two values are different. Okay, so let's see part E. It says find the predicted height to 1 decimal place for a second new classmate with a shoe size of 7.5. 7.5 should actually say there, not dot, not comma. Sorry, this is a point. We're talking English, so this is a point. Okay, 7.5. So now we're given a y value, right? Shoe size. So in this case, we should use this equation over here in order to predict the height of this second classmate, the second new classmate, right? So I'm going to take this equation down there, which is the x and y equation. So this is part E. I'm going to erase this. And we would solve this. We want to predict the height of this second new classmate. So this is 3.39 times 7.5, which is the shoe size of this person, plus 142. So if we solve this using a calculator, we would get the predicted height, 3.39 times 7.5 plus 142. And we get 167 0.4 rounded to 1 decimal place. This is centimeters. So this is the predicted height of a person with a shoe size of 7.5, which is something reasonable. There you go. Something reasonable. Maybe we'll get, again, kind of the same answer, because you see, if we go to 7.5 in shoe size, 7.5 in shoe size is 2, 4, 6, 8, somewhere around here. Yes, and you see that both lines are very, very close together during this interval over here. So maybe the answer would be very similar. But once again, we're gonna try doing this. But in this case, the equation that we should not use is actually this one, right? That's the equation y on x. So I'm gonna erase this and change the style to blue. So if I try now, remember we have the value of y and we want to predict the value of x. So I'm gonna plug in the value of y here, which is 7.5. Sorry, I'm using blue. 7.5 equals 0.256. X is 100. No, sorry, I want to predict x. X minus 35.0. So if we solve for x, this would be 7.5 plus 35 gives us 42.5. So 42.5 equals 0.256x. Finally, if we divide both sides by 0.256, we'll get this value, which is 166. So yes, so in this case we get a slight difference, 0.0 centimeters. So you see that in this case, I'm gonna make sure this is clear. This is not correct to do, and this is not correct to do. And this is correct, and this is also correct, okay? So you see that we get a difference between these two numbers over here. And obviously this number would be much more reliable than this number over here. Okay, so that's something that you should always keep in mind, people, when you're finding or using the regression equation. Normally for an IB exam, you would be asked to find this equation, which is y on x, and most of the exercise will ask you to find predicted values of y given values of x. So you wouldn't have to worry much about this concept during the IB exams, but maybe, who knows, in some exercise you may be asked to find this, and you should remember that this equation is a totally different equation from this one, okay? And that's what I showed you today, how to find. And okay, that's it. So I hope this was clear enough for you. If there are any doubts, do not hesitate to ask me in the Google Classroom or WhatsApp, however you want, okay? So see you